We present GlobalMapper for arbitrary-shaped urban layout generation. GlobalMapper fits arbitrary road networks and complex layout designs. It successfully generates heterogeneous and realistic scenarios across 28 cities in North America. GlobalMapper supports continuous city generation with high fidelity and diversity comparing to real layouts. Its light-weighted network accomplishes city-level generation in minutes. By latent inversion and manipulation, we also supports multiple ways of controllable generation between different cities or different patterns. Moreover, GlobalMapper enables 100% covered generation given only partial layout priors by distance-weighted latent inversion. It successfully addresses data equity issue for cities with severe data missing. Supporting wide range of data coverage, our generated vector-based 3D layouts are suitable for broad downstream urban researches, including weather simulation, 3D visualization, and demography synthesis. Our project origins from data equity problem in urban researches, that medium or small cities covering most population are extremely lack of data coverage. Our goal is to generate the entire city given the learned representation of urban layouts. However, prior layout generation methods assume trivial assumptions of rectangular-shaped canvas and layouts. While for realistic urban scenarios, it's hard for those works to capture arbitrary building and block shapes. While in this work, our contributions include graph-based representation of urban block, canonical spatial transformation for arbitrary-shaped urban layout generation, and controllable generation based on partial input priors. Specifically for arbitrary-shaped city blocks, we introduce canonical spatial transformation. The skeleton of the city block shape is calculated as the main axis of building assignment. The location and size of each building is normalized to canonical form according to the main axis. For arbitrary-shaped buildings, we introduce multiple building types and occupancy ratio. Each building will be assigned a shape type and an overlapping ratio over its bounding box. Afterwards, we represent each city block as a 2D grid graph. Each building is represented by a node, and its geometry and spatial information is encoded as node attributes. Edges between nodes represent relative spatial relations between buildings. This representative graph is the basic format for our training. We train our graph attention networks in a VAE manner, and our dataset is from OpenStreetMap. The total training time is 9 hours for a single RTX A5000 GPU. Compared to former works, GlobalMapper provides faithful layout generation supporting arbitrary-shaped building and city blocks, while competitors suffer mutual overlapping and out-of-block layouts. We compare 1,000 unconditional generated urban layouts to realistic ones. GlobalMapper provides the best performances on multiple metrics regarding overlapping, alignment, realism, and out-of-block layouts. Our user study supports that GlobalMapper generates layouts more similar to realistic ones. We further discover that our canonical spatial transformation may also improve performances of other methods adopting arbitrary-shaped cases. Our near-future work including expansion to 331 cities in US with more than 100K populations, and city-level representation learning. Thanks for listening. Please refer to our paper and website for details.